So for our final ModCon project, we built a two-part circuit. The first part with an automatic dimming light, and the second part with a hysteretic oscillator that's connected to a speaker that would change in pitch as you darkened the photoresistor on the other side. So for this first resistor, we have two op amps. One of them acts like a comparator, and then what happens is it compares the resistance of these two resistors to the capacitor over here, and then when the capacitance, when the voltage of this capacitor is lower than these resistors, it sets off the timing mechanism for the second part, which is the amplifier. The amplifier amplifies the change in this capacitor, and then that comes out to the LEDs. And then what happens is, because we have a photoresistor here, as we bring our hands in and out of this photoresistor, the lights dim and they get brightened. So we can see that as the light is flashed over the photoresistor, the LEDs are getting dimmer and brighter.
And as the voltage across the LED changes, that voltage is being passed through this buffer here, which connects to the hysteretic oscillator. So as the voltage across the LEDs increases, the frequency of the hysteretic oscillator should also decrease. On the other hand, if the voltage across the LEDs is low, then the frequency of the hysteretic oscillator should be high.
So in this video, we can see how the oscillations are being affected by the voltage that's gradually decreasing from the first part of the circuit. As the input voltage to the light theremin section of the circuit is going down, the oscillations are also decreasing.
So as the brightness decreases, as I put my hand over it, the frequency of the oscillator decreases. That's because it takes a longer time for the oscillator to reach the voltage that the LEDs are currently in. Whereas if I take my hands away from it and bring it closer to the light, the oscillations become a lot smaller. And the less light, more light, less light, more light.
And here we have our LED dimming circuit. So on the left we have our timing part, and on the right we have our actual dimming part of our circuit. So on the left we have capacitor C1, which discharges through the resistor R1, and this is compared to a voltage set by the photoresistor and the resistor R2. And what happens is when C1 goes below this reference voltage, op amp O1 goes high, and this lets the dimming part of the circuit begin, and O2 is just a operational amplifier, and it amplifies the changes from as C2 is discharging, and it decreases the voltages going through the LEDs.
In the second part of our circuit, we have the LED system connected to a buffer, which transfers the voltage to a hysteretic oscillator. So as the voltage across the LEDs decreases, the frequency of the hysteretic oscillator increases. Inversely, if the voltage across the LED increases, the frequency of the hysteretic oscillator increases. Now, the output of the hysteretic oscillator is then connected to an inverting amplifier, which amplifies the signal of the oscillator, and that amplifier then transfers the voltage to a speaker, which produces sound based on how the setting of the photoresistor.